Hello students. Today we explore one of the most fascinating ideas in physics, refraction of light. Why does a pencil look bent inside water? Why do we see sunrise earlier than the actual sunrise? Why does a lifeguard run in a zigzag path to save a drowning child? Let's understand all of this using refraction. Refraction is the bending of light when it travels from one transparent medium to another due to a change in speed. Light travels fastest in vacuum, slower in air, slower in water, and even slower in glass. When the speed changes, the direction changes too. This is refraction. When you look straight down into a swimming pool, the bottom appears closer than it actually is. This is because light bends away from the normal when it moves from water to air. Our brain traces the rays backward and forms an image at a shallower depth. Now if you look from the side, the object appears shifted sideways as well. This is called lateral shift. This explains why fish in water appear at a different position when observed from land. Did you know we see the sun 2 minutes before it actually rises? And we keep seeing it for 2 minutes even after it has set? This happens because of atmospheric refraction. Our atmosphere is denser near the surface and thinner above. Light from the sun bends gradually as it enters denser layers. This bending makes the sun appear slightly higher than its real position, so we see it even when it is actually below the horizon. A famous real-life application of refraction is Snell's law. A lifeguard wants to reach a drowning child quickly. Running on sand is faster than swimming in water, so the quickest path is not a straight line. Instead, the lifeguard runs along the beach, then enters the water at an angle. This minimum time path follows the same rule as refraction of light. Light takes the path of least time when changing medium. This is exactly described by Snell's law. Snell's law mathematically describes how light bends, where I is equal to angle of incidence, R is equal to angle of refraction, mu21 is equal to refractive index of medium 2 with respect to 1. Higher refractive index. Light bends toward the normal. Lower refractive index bends away from the normal. A coin is placed at a real depth of 12 centimeters in water. What is its apparent depth? Solution: di is equal to dr, mu is equal to 12/1.339 centimeters. The cone appears at 9 centimeters instead of 12 centimeters. A light ray travels from glass to air and strikes the surface at an angle of incidence of 50 degrees. Find the angle of refraction. Solution: use Snell's law. 1.5 sin 50 degrees is equal to 1 sin r, 1.5 is equal to sin r is equal to 1.149. But sin r cannot exceed 1. Total internal reflection occurs. So no refraction, only reflection. And that is the fascinating world of refraction, from swimming pools to sunsets, from lifeguards to lenses. Keep learning, keep questioning. See you in the next lesson.